This is Porter Thorndike with a demonstration of ML functions for WebFOCUS, accessible through the data flow mode of the data preparation environment. First one I want to look at, anomaly detection. And we're looking at data of bank customers and ones that have stayed or left. As we look at some of the settings, we can score it binary, or we can do a grade, a lot of settings, but we can just run and train this model, and you'll notice we're getting a prediction on which ones are anomalous. And so right now, as we look at the histogram, it is saying, we only found 0.55% of these that are anomalous. That's a very small tail. You might have subject matter experts that actually know what a normal percentage would be of anomalous transactions, or that they could tweak that setting to say, we actually expect 5% of these to be anomalous. Okay, and so that can just adjust the threshold with which it is identifying which transactions or bank customers or values that we find anomalous. And we see right there. The other thing that we can do though here is we get into the settings and we tweak it. And sometimes you don't just want a binary prediction. Sometimes you want what is the confidence. So we can change the scoring from binary to grade. And in this case, what we're going to get is we're going to get the confidence that this is an anomalous transaction. So as you might imagine, you could sort this. We could, break apart the ones that we think are most fraudulent or most anomalous. You might hand those off to investigators to look into in greater detail. The next model I want to look at is a binary classifier. The binary classifier, it's got a number of algorithms that come with it as well. In this case, we're looking to predict the attrition flag. We can select our input variables. As we take a look at the settings here, you can see the 4 different algorithms that are going to be used. Important to select some things like the positive class, which in this case is the attrited customer. You'll notice we're using 80% of the data to train it, 20% of the data to then test it against. We can see which ones did the best with the F1 score. It's the extreme gradient boosting. We're also giving you accuracy, precision, and recall. If you like one of these and you want to be able to save that and apply that to new data, that's exactly what we can do. I'm just going to save this and put in my author name and a description of the model. We've got nice textual descriptions of how these things are calculated. It's all about true positives, false positives, true negatives, and false negatives. We can at any time kind of look at the sample data, see what was predicted in the actual data and what the prediction was made. We can zero in on the evaluation of those scores. We can look at the confusion matrix to see how many false positives and false negatives, true positives, true negatives were made. We get a visualization of the ROC curve and the optimal decision threshold, which will be useful. You want the best AOC score there. We get the precision recall curve, a lot of information, textual descriptions to help non-data scientists leverage these models to enrich and prepare their data. Of course, we can make some customizations, change this from binary to more of a probabilistic or score type of classifier. The other one that I want to look at really quickly is regression. If we were looking at predicting heating and cooling loads for houses, might be an example. Again, select your input variables, and then you get a visualization of those different algorithms and which one, based on the regression, which one was most successful. Now, if we want to take it the distance here, and we want to take new data on new bank customers, and we want to score them based on all their input variables in that model that we already created, we've got a lot of different functions out of the box that we can use. One of these is run model. And this is what's going to allow us to map that saved algorithm into the new data, and we'll make a prediction for us. So I'm going to click on the run model function with my new data, and I'm going to find that saved model. It's called extreme gradient boosting. I'm going to say OK, and what this function is doing is looking at that new data and making a prediction. based on all those input variables in the model that was already trained. So that is how we do it with WebFOCUS and ML functions, taking it the distance, really from start to finish. Here, as I scroll to the right, you'll see the prediction that was made.